Okay, so we're going to take a look at page 555, number 25, which reads, we have this equation plus 9 over 3x minus 1 times x squared plus 1, and that's going to be equal to a over 3x minus 1 plus bx minus c over x squared plus 1. So we have this equation, and we're to find the values of a, b, and c that make this equation true. So this process is what's called a fraction decomposition, and if we have basically the answer to a common denominator problem here, and we want to break it up into these terms with these two denominators, what values are we going to put here? Now, although that's something that would be a bit advanced for this course on its own, this right here, the finding of A, B, and C in this form, that's what we're going to use, and it's basically going to come down to a 3 equations, 3 unknowns problem. We have our 3 unknowns, and to solve for those 3 unknowns, we just need to develop our 3 equations. So if we were to take a common denominator on this side, we should get that side. So let's go ahead. We can already see the denominators match. So what we'll get is a times x squared plus 1 plus bx minus c times 3x minus 1 over our common denominator. And we'll expand and simplify this and get x squared plus a plus 3bx squared minus bx plus 3cx. I think this right here is supposed to be plus down all the way down here because I'm going to end up with a minus c there. Okay, and that's going to be over the same. So what I'm going to do here is I'm going to collect like terms in a way. So I've got an x squared and I've got an x squared there. So I've got x squared, and I'm going to have an a plus 3b. I've got an x and an x here, so it'll be plus x times minus b plus 3c, and then the rest is plus a minus c, and that will be my constant term. Now you'll see why I'm grouping them like this, because this is supposedly equal to 11x squared minus 14x plus 9 over 3x minus 1 times x squared plus 1. Now, in order for this fraction to be equal to this fraction, and the denominators are the same, then their numerators need to be the same. Now, in order for that to be true, I've got an x squared term, an x, and a 9. Over here, I've got an x squared term, an x, and a constant. The coefficient here needs to be equal to the coefficient there. The coefficient here needs to be equal to the coefficient there. The constant needs to be equal to the constant. So from there, I can write my three equations as a plus 3b equals 11, minus b plus 3c equals minus 14, and a minus c equals 9. So I've got my 3 equations, and I've got my 3 unknowns. So now it comes down to solve those. So I can eliminate a by going 1 minus 3. A minus a will be 0. Then I'll get 3b plus c equals 11 minus 9 is 2. That'll be my equation 4. And now I've got an equation 4 and an equation 2 with the same 2 variables in it. So I can go back and eliminate either b or c from that. I suppose I'll eliminate b by going 3 times 2 plus 4, and I'll get 3b plus 3b, negative 3b plus 3b is 0. 9 plus 1 is 10c, and this will be minus 42 plus 2 is minus 40. C equals minus 4. Sub c equals minus 4 in, I don't know, 4. And I'll get 3b minus 4 equals 2. So 3b equals this is be 6, b equals 2, and then I'll sub both of those. Sub b equals 2, c equals minus 4. I suppose I don't need both. I'll just sub them into 3. I'll just need this one in 3, and I'll get a plus 4 equals 9, so a equals 5. So my fractions that I need are 5 over 3x minus 1 plus 2x plus 4 over x squared plus 1 will be equal to what I'm looking for, my original 11x squared minus 14x plus 9 over 3x minus 1 times x squared plus 1. Okay, thank you.